Hey there, matriculant. A big warm welcome to today's trigonometry session, proudly brought to you by the Learning Space. If you're joining us for the very first time, my name is Tepang Khati. Today's session is especially paced for you and focused for you, our rising stars. Whether you're joining us on Zoom or TikTok, you're in the right place to ask questions. Please remember to take your time and get the support that you need. Before we start the session, please don't forget to like the session, subscribe, follow the Learning Space, right, on our various platforms: YouTube, Facebook, TikTok, Instagram. Share it with your classmates, because success is better when we all win. All right, now we're going to be looking at trigonometry for today. Okay, I'm going to share my screen. Please make sure that you do have your pen and paper and calculator. There are a lot of questions that we have to deal with for today. Okay, remember, there is a Q&A section that you can utilize if you have questions for us, and also you can rely on the chat for some of those questions. All right, I'm seeing hands that are raised already. Maybe let's address those questions before we actually start with today's session. I'm going to ask my colleagues to assist us with unmuting the guys who have their hands raised, and then we will start with the session. There's Lina Ndlovu who has their hands raised. Maybe let's just, okay. Lina, you can go ahead. Lina, if you have a question, please do go ahead. We are listening. Okay, maybe it was a mistake. There's Dennis and then there's Sean. Dennis, you can go ahead. Dennis, you can unmute yourself and go ahead with your question. Okay, maybe they are covered. Let's try Sean. Sean, you can go ahead. Okay, I'm assuming those were some mistakes. Let us proceed with the session just for the sake of time. Okay, for now, I'm not going to address any hands. If you have questions, please do post them in the chat or the Q&A so that we can at least get started. Otherwise, we are going to waste a lot of time. Okay, so there is a question in the Q&A. Can I firstly analyze finance? We did finance yesterday. The recordings, if they're not yet up on YouTube, they will be up by the latest tomorrow. So yesterday was when we did, sorry, on Monday. Today is Thursday. Sorry, on Tuesday we did finance, and then yesterday we did functions. If you missed those, please do check our various platforms and our website. Okay. Cool. Now let's start with some revision, or some of the things that you need to know. Those are the crucial things that you need to know for this topic in your grade. I know you did it during the first term of this year. So let's see if you still remember some of those things. Okay. As usual, I'm going to start with some explanations, and then we will tackle the questions a little bit later. All right. Now we're going to be starting with the cast diagram. We all know what the cast diagram is. It was introduced in earlier grades, especially grade 10 and then grade 11, right? Now we know that we are dealing with the four quadrants there. So 1, 2, 3, and 4, and we go anti-clockwise. So this is the first one, and then we go anti-clockwise. Now in the very first quadrant, all our ratios, all our three ratios are positive, right? The three ratios that I am referring to in this case are sine of theta, cos of theta, and tan of theta. So all three of those are positive in the very first quadrant. Okay, now why are they all positive in that quadrant? We need to remember that in quadrant number one, the x values are positive. Remember, this is the positive side of the x-axis, and this is the negative side of the x-axis. And then this is the positive side of the y-axis, and this is the negative side of the y-axis. Now, because we're in this quadrant, we can draw maybe a triangle that looks like that. If we consider sine, we know it is y over r. The y values here, like I said, they are positive, and r, since it's a distance or it's a radius, it will always be positive, right? So we have a positive over a positive. That's why sine is positive in the. So is cos. Cos is also positive and r is also positive. That's why cos is positive. Then tan, we simply know it as what? As y over x. Since the y values and the x values are both positive, positive divided by positive will still give you a positive. And that's why all of them are positive in that quadrant. Now, doing only one, maybe let me do the third quadrant, the tan quadrant. Why is it only tan that's positive in the third quadrant? Now, let me just draw a triangle like that. We know that the y values here are negative, the x values are negative. Now, if we said sine in that quadrant, remember I'm in quadrant 3, let me just say, so Q3. If I said sine is the y value, which is negative, and r is positive. Sine is negative in there. Now, if I said tan, it's going to be negative y, and then x is going to be what? Negative as well in the third quadrant. So negative and negative, those deal with each other there. Then it means that we are actually dealing with a positive thing, which is the positive y over the positive x, which gives us a positive tan. And that's where the cast diagram comes from. All right, perfect. Now we use this to what? To reduce complex trig ratios into simpler ones, often resulting in a single value. All right. Then we also have what? Co-function identities, right? Now, what are co-function identities, right? So these are just simply known as co-functions. This is when you have what? Sine of 90 plus or sine of 90 minus. But also it can be cos as well. Right, so if you have cos of 90 plus or cos of 90 minus, those are co-functions, right? Now we need to remember that sine of 90 plus is a co-function. Now we need to check, where is 90 minus theta? Okay, which quadrant is that? It's going to be in quadrant number 1, 90 minus theta. What do we know about sine in this very quadrant? We know that it is positive. So we have a positive sign there, right? Sine, I mean this, not the ratio, but positive. Okay, then it must change. What is it going to change to? It's then going to change to cos. And that's how you deal with it. Okay, now let me explain cos of 90 plus. We need to check, where is 90 plus? 90 plus is in which quadrant? It's in the second quadrant. This is where we find 90 plus. Now, what do we know about cos in this quadrant? Cos is negative. That's why we attach a negative sign first. Now we know we're dealing with 90 plus, then it must change because it is a co-function. It's going to change to what? To sine. And that's how we deal with it. The order is very important. Otherwise, you end up making some mistakes. So make sure that you do it in the correct order. Okay. And if you want to take them down, you're more than welcome to quickly do so. But remember that the notes will be made available to you after the session. Otherwise, if you want to take quick notes, just take screenshots on your phones. Okay, now quickly moving on to compound and double angle identities. Right. Now, these ones are given on the formula sheet. You do not have to memorize. Okay, please try not to memorize these. You must just be comfortable with them. You must know which one you need to apply. All right. Now, right. So what I did here is I just compressed them because of space them. But for sine, you just rely on your formula sheet. The only thing that changes is the plus or the minus sign. Okay. Now you'll see when we apply this, we're going to come back and just copy them as they are here in order for us to actually solve these kinds of problems. Okay. Now, the easiest one that I can explain would be, maybe let's look at sine. Okay. Now we know that whenever we're dealing with sine, let me just make a very simple example there. Sine of A plus A. If we expand that, what are we going to have? We're simply going to have what? Sine of A, cos of A plus what? Sine of A, cos of A. And what does that give us? That will simply become, because these two things are exactly the same, we're going to get 2 sine of A cos of A. So the sign only changes for cos. Okay. And then furthermore, we also have the double angle identities, which are also given on the formula sheet. Do not memorize, you must just practice so you know which one you need to apply. The one for sine 2x is going to change to 2 sine x cos of x. Right, that is the only option that we have there. And then we also have the one for cos. Right, now the one for cos, I always like to start it here. Cos squared x minus sine squared x. The reason is afterwards, if I want to change the sign to cos, I know that I simply change it to 1 minus cos squared x. Or if I want the one that only has sine, I will change this cos squared to what? To 1 minus sine squared x. So if you never know which one you need to apply, then always rely on this one. Okay. I'm hoping that is clear to everyone. Now quickly moving on. In your grade, you'll see that they like the Pythag-based questions, right? Where you have to rely on the theorem of Pythagoras to solve some of these questions, because you are going to be dealing with a 90-degree triangle. And a lot of students struggle with these questions. Let's see how we can help you to tackle these kind of questions. So for example, here we have cos of 63 is equal to k. What is it that you know about cos? You must ask yourself. You know that cos in terms of x, y, and r. Cos of theta is simply x over r. That's very important. Once you're here, you know that this is going to be what? This is simply k over 1. Remember when you say k over 1, you are not changing anything. All right? Now, if that's the case, it means that we have the x and we have the r. Then you need to remember something. There's a guy who can help you with this, and that guy is theorem of Pythagoras, or just Pythagoras. Okay, remember that for Pythag, the formula is just x squared plus y squared is equal to r squared. Now substitute what you have. You have x, which is k squared. You don't know what y is, but you do know what r is. It's 1 that needs to be squared. And then you simply solve for what? You simply solve for y. If you try to solve for y there, you're going to get y squared is equal to 1 minus k squared. Right? Now, this, we know when we get rid of a square root, what do? We say plus or minus This is going to be 1 minus k squared. Do not fall into the trap of saying this is 1 minus k. Remember, we need to deal with inside, with whatever is under the square root first before we cancel that 2. Don't say the square root of 1 is 1 and the square root of k squared is just k. It doesn't work that way. You need to find what 1 minus k squared is first, and then, only then, get rid of the square root. Now, after saying plus or minus, which one are we going to pick? We have to pick the positive one. Why the positive one? Because of the angle. The angle is 63 degrees. If you're dealing with 63 degrees, you are in the first quadrant where the y values are all positive. Okay, I hope that makes sense there. And then once you have this, it's going to be quite easy for you to solve the subsequent questions. So the question A is saying sine of 27, and we know that for us to find sine of 27, we can rely on cofunctions. I just explained cofunctions. 27, how do we get 27? We know that 27 can be 90 minus 63. Why do we want 63? That's the angle that was given. And then once we have 90 minus 63, remember this is a what? This is a cofunction that we dealt with. Sine 90 minus has to change to cos of whatever theta is. And in this case, theta is 63 degrees. So we have cos of 63 degrees, which simply means that our answer is K. Okay, there's a question. How do you record? Also, we are recording it on our side, and then it will be made available tomorrow. So just check our website, check our YouTube, and check our TikTok. You don't have to do any recording on your side. Perfect. Now, moving along. Some of these things I want to explain when we are actually doing the questions together. All right. So I'm just going to skip for the sake of time. Now, you need to remember some of the basic identities that we dealt with in the earlier grades. The most important one is the Pythagorean identity. I call it the Pythagorean identity because to me it looks like Pythag, right? Which one is that one? This is the sine squared theta plus cos squared theta is equal to 1. That's very important. Why is it even 1? It's 1 because remember that sine is y over r. But we're dealing with sine squared, so I will square it there. Plus, what is cos? Cos is x over r. But we're dealing with cos squared. That's why I'm going to put a squared there as well. All right. Now, what are we dealing with? Now, we are dealing with y squared over r squared plus what? Plus x squared over r squared. Now, can you see that we have a common denominator, which is r squared? So I'll just write 1r squared, then I have y squared plus x squared. But according to Pythag, what is this equal to? What is the top equal to? It's equal to r squared. Then it's over what? Over r squared. Now, what is r squared over r squared? It's equal to 1. That is why this identity gives you 1. Okay, now from there, you need to be able to play around with that identity. So don't worry, you do not have to know the proof. It's just that I like to explain using the proof sometimes so that at least you know where it comes from and why it works every single time. You don't have to know the proof, you just need to remember it. And you also need to be comfortable with what? With playing around with it. Because we have this first one, and then we solved for sine by taking the cos over to the other side. It became negative, right? We subtracted cos on both sides, and then we have 1 minus cos squared. Also remember that this is what we call dots. So 1 minus cos squared theta, that's the difference of two squares. You can simplify it to become 1 minus cos of theta into 1 plus cos of theta. And that is how you deal with that one. Okay. You can also do the very same thing for sine, right? If you have 1 minus sine squared theta, that will change to 1 minus cos theta, another bracket of 1 plus cos of theta. And you must be able to solve for sine and cos. Then remember that tan of theta is what? Tan of theta is sine of theta over cos of theta. Luckily in metric, you don't have to worry about cosec, sec, and cot. You just have to remember the three basic ones being sine, cos, and tan. Okay, perfect. Now, I want us to move on to some problems and then we'll come back to the summary notes. Because I'm seeing that in the next thing that I wanted us to talk about were the quadrant-based problems. And a lot of students struggle with these. It'll make more sense when we actually tackle a problem. Let's check here. In the diagram below, point S has coordinates what? -4 and Q. A reflex angle theta and reflex angle theta are shown. O is the point at the origin. OS is 3 root 2. That is the length of OS. Without using a calculator, right? That's very important. Without using a calculator, they will ask you these kind of questions where they want you to just solve them without relying on a calculator. It shouldn't be too much of a challenge for you guys. Let's check. Q, what do we know about Q? Remember we have coordinates X and what? And Y. And then what is it that we can say? OS is what? It's the radius. I'm pretty sure you can immediately see that we can rely on Pythag. I'm hoping it's clear for everyone. Now, X squared plus Y squared is equal to R squared. Okay, let's substitute. What is X? -4. Please be very careful. Because it's a negative, you have to put that negative inside the bracket. Remember that -4 squared is not equal to -4 all squared. Those two things are not equal. And you can put it to the test. You can check your calculator. You'll see this one will say -16 and the other one will say +16. Right, perfect. Otherwise, you make a silly mistake and then it doesn't work out. Y, we know it is Q squared. And then R is 3 root 2 squared. 16 plus Q squared is equal to what? It's equal to 9 times 2, which is 18. If I'm making a silly mistake, please do correct me. Okay. Q squared is equal to 18 minus 16. And then Q squared is equal to 2. Q is what? Plus or minus square root of 2. Now, remember something else. We are dealing with the third quadrant. What do we know about all the y values there? They are going to be negative. So Q is negative the root of 2. A very easy 2 marks to obtain there. Yes, Zakari, there's a line from origin, always use it as a circle. Yeah, you can use it as a circle, or alternatively, you can just complete the diagram such that you have a triangle. And then you know this is the y values, these are the x values, and this is r. Okay, perfect. I hope we're all together there. Now let's check this one out. Now we need what? Sine of theta plus 45. Let me just write that there so that I don't forget. Now, sine of theta plus 45. Let me just do this. I'll write it on top here. How do we expand this? Remember what I said. This is given on your formula sheet. So you do not have to memorize. Look at the formula sheet and then substitute. This is your first angle and that's your second angle. When we expand it, we're going to get sine of theta, that's the sine of the first angle, multiplied by cos of the second angle, and then plus cos of the first angle multiplied by sine of the second angle. Just like that, we've expanded it. Please make sure that you are with me every step of the way. Otherwise, please pop a comment in the chat or raise your hand. Now, sine of theta. What do we know about sine of theta? It becomes what? Y over r. But what is the y value? The y value is negative root of 2. And what is r? R is 3 root 2. And just like that, that is the value of sine. Let me start substituting what I have. This is negative root 2 over 3 root 2 in brackets. Open brackets again. What is cos of 45? We know that is root 2 over 2. It is a special angle. Plus, now cos of theta. What is cos of theta? It is the x value over r. What is the x value? Negative 4, and r is 3 root 2. So I'm going to substitute that. Negative 4 over 3 root 2, and then root 2 over 2. Just like that. I'm hoping that makes sense. And then all you do here, so please pay careful attention to what I'm about to say. What did they say? Without the use of a calculator. Yes, I'm acknowledging that. They're saying without the use of a calculator. What they're simply trying to say to you is show all of the steps and do not write decimals. So show them all the steps. Okay? What do I mean by that? You're going to, even though they said without the use of a calculator, here you are going to use your calculator to find what that is. But do not write the decimal. Let me see. No decimal. I'm hoping that's clear for everyone. You can use your calculator there, but do not write a decimal. I cannot make it any more clear than that. And then you do it step by step. The first part gives you negative root 2 over 6. And then you're going to do the same for this as well, with a plus d. Then afterwards, you are going to just add these two. And your final answer should simply give you negative 1 minus 2 root 2 all over 3 root 2. Hoping that's clear to everyone. Okay. Okay, so there's a question in the chat. The x and y values in the third quadrant are always negative. Yes, they are negative. Think of a Cartesian plane, an xy plane. This is the origin, O. When we go to the right, we're increasing. So this is positive 1, positive 2, positive 3. When we go up, we're increasing positive 1, positive 2, positive 3, positive 4. When you go to the left, 1, negative, 2, negative, 3, negative. When you go down, 1, negative, 2, negative, 3, negative. So these ones are negative and those ones are also negative. Okay, and that's how we deal with 5.1.2. Okay, so why is the reflex angle used? Angle in the triangle for sine. Okay, Zachary, I'm going to ask you to maybe rephrase your question. I'm a little bit confused there, but remember that a reflex angle is one that is bigger than 180 degrees, right? Because it's bigger than 180 degrees. It's in the third quadrant. It's not in the S, but it's in the T quadrant. So CA is T. Okay. Okay. We are getting the same answer, so I'm guessing we are on the right track. Okay, so let me just address some of the questions. So when there is data, we use the graph given the triangle we make, and then we have actual angle sizes like 65. We use graphs. We should have studied. Okay, so yeah, when you're given theta, you have to make a triangle for yourself. Okay, and then usually they will give you a restriction. I think I do have a question like that where they give you a restriction. They'll tell you that theta lies between maybe 270 and 90, something like that. And then they'll also give you something else where you have to determine the quadrant. Okay, now moving on. All right, could have made a mistake. I'm seeing that people are getting a different answer. If you are seeing my mistakes, please do correct me. Okay, I'm just going to quickly recalculate with you guys. If it's a mistake on my side, I apologize. I do make silly mistakes here and there, but I'll try to be very careful so that mistakes do not happen again. Root 2 over 2, and then plus a negative 4 over negative 4. 3 root 2. There we go. Multiply by root 2 over 2. Okay, silly mistake on my side. You guys are saying it's negative 4 plus 2 plus root 2 over 6. Okay, we're all happy now. Let's quickly move on. Now we need to find cos of 2 theta minus 360. Okay, now notice something. What we are comfortable with is when the theta is on the right hand side. We like 90 minus, 90 plus, 270 plus or 270 minus, or 360 minus, 360 plus. But when you have the theta appearing first, that becomes a bit of a challenge. Okay, let's enlarge this a little bit. There we go. We need to rearrange it. So this is the same as cos of, check something. The 360 is negative. The 2 theta, is it positive or is it negative? It's positive. Right, I'm going to do it step by step so that you guys can clearly see where I'm coming from with this. Then, whenever we are dealing with negative angles, what do? We add 360. And where do we add the 360? We add it in front. Now check something. That and that cancel each other out. So it simply means we're dealing with what? Cos of 2 theta. Okay. Now, what is cos of 2 theta? Where are we going to get this? We're going to get it from the formula sheet. The double angle for cos. Right. I'm going to use which one? I'm going to use the 2 cos squared theta minus 1. But even if you use the 1 minus 2 sine squared of theta, or the cos squared theta minus sine squared of theta, it was still going to work out. Once I have this, it's just a matter of substitution. What do I know about cos of theta? It's what? Negative 4 over 3 root 2. And then square it. minus 1. I hope everyone is with me so far. If I've lost you, remember to utilize the chat to ask your questions. I think we're all on the same page. Okay, here's a question. So why do we add the 360, right? Now we add the 360 only when we are dealing with negative angles, right? So the reason is negative angles are difficult to comprehend. Well, for me, they are quite difficult to deal with, and we want to make it easy for ourselves by adding 360, all right? Now, if you add 360, remember that when we're dealing with trigonometry, we are going, whenever we measure angles, we are measuring them anti-clockwise. Now, if you are dealing with a negative angle, it's just a matter of direction. They took the clockwise direction. So you want to take it back by adding 360. Okay, hoping that is clear. And then here, our answer is simply going to be 7/9. And that is the final answer. Do we add 360 even if the angle is small, like -60? Absolutely. Whenever we're dealing with negative angles, add the 360. Perfect. Everyone is getting the 7/9. And that's how you simply get your 4 marks. You cannot afford not to get those marks. And to the guys who are watching us live from TikTok, if you'd like to be part of the discussion going on Zoom, please do check the chat. The link should be posted for you to join us on Zoom so that you're able to ask the questions that you might have for us. Right. Otherwise, the guys who are on Zoom already, please remember to share the link with your friends or the groups that you guys are a part of at your schools so that we can share the information. Great stuff. There's another question. For tan, if there is a negative angle, do we add 180 or 360? So for negative angles, you always add 360. Even if it's for tan, you must add the 360. Great stuff. Now, simplification, right? Cannot afford to lose marks here. All right, let's deal with this question. Sorry about that. Here we go. I'm hoping everyone can clearly see the question. Simplify the following without using a calculator. It shouldn't be a problem at all. And I'm going to write text so that you guys can see where I'm going, where you're going to get your marks. Right. Now let's address something. Remember, if you want me to repeat something, you need to be very specific with what you'd like me to repeat. You cannot just say repeat. Otherwise, I just move on. For the sake of time, you need to say, sir, repeat this part. You lost me here and there. You need to be very specific with the request. Okay. Now, 5.2. What did we start with? We started with co-functions. You can immediately see that this is a co-function, right? Now, if it's a co-function, where is 90 minus? It's in the first quadrant. Because it's in the first quadrant, it has to change to what? To cos. So it's going to be cos of theta in brackets. Okay, this is a fraction. I'm just going to write my fraction line there. Now, can you see that we are dealing with an angle that is bigger than 480? LT, I will give you some questions for you guys to attempt. I just want to do a quick example of how you need to tackle some of these questions for the guys who are not so strong with trig. But I do have questions prepared for you guys. Now, whenever you're dealing with such angles that are bigger than 360, you have to subtract 360 from them. Okay? So now you say 480 minus 360 because they are bigger than 360. Then you're going to have 120. It means that we're actually dealing with cos of 120. And then now we need to think, where is 120 located? Which quadrant? It's in quadrant number 2. What do we know about cos in quadrant number 2? It's going to be negative. What is the reduction formula for quadrant number 2? It is 180 minus theta. But what do we want to get? We want to get 120. So what do we need to subtract to get to 120? We need to subtract 60. That is why we have cos of 60, which is negative. Then the plus is still there. Now we have what? Cos of 180 minus. All right. Now cos of 180 minus is simply going to become what? Negative cos of theta. Now moving on. Cos of theta, sine of 150. So cos of theta, I cannot do anything there. Write it as cos of theta. Sine of 150 is the same as sine of 30 degrees. How did I get sine of 30 degrees? 150 is in the second quadrant where sine is positive, and then it's 180 minus what? Minus 30 to take me back to the 150 that they need. Then minus what? Minus 10 of 180 degrees. Cannot do anything there for the 180 for now. Yeah, when you're dealing with these kind of calculations, you want to reduce these to special angles so that you can substitute, because we do know the values for special angles. Right, here's a question. So on the numerator, why do we have negative cos of 60? Remember, I explained why it's negative cos of 60, because the 480, we subtracted 360 from it, and then it became 120 degrees. 120 degrees is found in the second quadrant where cos is negative. Right. Now, what is the reduction formula for the second quadrant? It's 180 minus. What do we need to subtract from 180 for us to get 120? We need to subtract 60, hence the cos of 60 degrees, which is a negative. All right. Now, let's check what we can do. Up here, I'm just going to say this is cos of theta. Now, cos of 60, which is negative, it must give you what? 1 over 2. You can use your calculator, but do not write a decimal. I'm going to write in red there. No decimals. Right? You can still use your calculator, but no decimals, please. That's how I got cos of 60. And then this is simply going to change to negative cos of theta all over cos of theta multiplied by what? What is sine of 30? It's just 1 over 2. Are we all together there? Then check what tan of 180 is. It must give you 0. Not theta, but 0. Yeah. Okay, somebody got the final answer. Yeah, 180, 360, 90. You just type into the calculator. Those are also special angles, by the way. You can just plug them into the calculator. Now notice something. This is a half multiplied by cos of theta. What do I want to do? It's the same as saying negative half cos of theta minus cos of theta. Right? This is how I want you to think of it. This is negative half of x minus x. And then down here in the numerator, what do we have? We have half cos of theta. Now on your calculator, what does this give you? Negative a half minus 1. Of course, you cannot put the x's. It will say it's negative 3 over 2 cos of theta. Denominator, a half cos of theta. Cancel whatever we can cancel. This cancels that. And our final answer becomes what? Negative 3. Now, let's award those marks. You're going to get a mark there. You're going to get a mark for cos of 60. For sine of 30, that is a mark. So out of 5, even if you made some mistakes with your algebra there, you still got 3 out of 5. So do not leave this question out. Make sure that you know the quadrants, right? Okay, so you're going to get another mark and then another mark for the final answer. Even if you took out cos of theta as a common factor, that's perfectly fine. It was going to work out because you were going to have cos of theta outside here. Then you're going to have negative 1 over 2 minus 1 all over cos of theta multiplied by a half, where these two cancel each other out. And then this will still give you the negative 3. So for the third step, all we did is we multiplied half multiplied by cos of theta. What's this? Think of this. What is cos of theta multiplied by negative 2? Remember, brackets mean what? Mean multiply. So if you multiply this, you're going to have negative 2 cos of theta, isn't it? That's exactly what we have. Cos of theta multiplied by a half is negative half of cos of theta. That's me just explaining the third step. What happened to the negative cos of theta? This is the negative cos of theta that you guys are referring to. So we have like terms. We have negative half of x minus 1. So there's 1 there in front. Negative half minus 1. That's what happened to it. Okay, perfect. Moving on. Now here is a proof. Okay, I do have some questions prepared for you guys. Just let me attempt these ones just so I can show you how you need to go about them. Whenever you're dealing with trig proofs, what you need to do first is you need to pick the side that has a lot of work, right? Now you have the left-hand side and the right-hand side. Which one looks like has a lot of work? Obviously, it's the left-hand side. The right-hand side, there's nothing you can do there. So you'll be shooting yourself in the foot if you pick the right-hand side. So we're going to pick the left-hand side and then try to simplify it until we get the right-hand side. So LHS is equal to whatever they gave me. That's what we're going to be dealing with. Now, this is the same as what? This is the same as cos of x over 2 sine x cos x. Double angle for sine, double angle there. Minus cos 2x. I don't want to change it just yet. Okay? 2 sine x. I want to get the same denominator. I want to get an LCD. What can I do? I can multiply this by cos x over cos x. Then it means I actually have cos of x over 2 sine x cos x minus what? Minus cos x multiplied by cos 2x over 2 sine x cos x. Hope everyone is following. Then we have an LCD. Check exactly the same. This is what? Cos of x minus cos of x multiplied by cos of 2x with one denominator. Now, there's a question, why are we multiplying with cos of x over cos of x? So the thing is, we want to get the denominators to be the same. So here I have 2 sine x and I have 2 sine x. I also have a cos here, but I don't have it here and I want to put it there. But I don't want to change the value of the sum. And if you say cos over cos, remember that cos over cos is 1. So we haven't changed anything. That is why we multiply by cos over cos. That's what we need there. If we needed a sine, we're going to multiply by sine over sine. I'm hoping that is clear. Now, we can take out a common factor, which is going to be what? Cos of x. What are we then left with? 1 minus cos 2x over 2 sine x cos x. Now, let's cancel. This deals with that. Now, can you see that we have a double angle that we need to deal with? And what is that? 1 minus. Now check something. We can go up and do a little bit of a cheat there. We are trying to get sine. So I'm going to change this to 1 minus 2 sine squared x. That's what helped me determine which one I need to use. Remember, there are 3 options for cos. All right. This is still over 2 sine x. No, sorry. The cos we have dealt with, it's not there anymore. And this is 1 minus 1 plus 2 sine squared x over what? Over 2 sine x. Now, these two will deal with each other. 1 minus 1 is just 0. This 2 cancels that 2. One of the signs cancels the sign down there, and the final answer is sine of x. This means that the left-hand side is equal to the right-hand side. Okay, now there's a question, is there another method besides this one of multiplying by cos over cos? Of course, there is another method. This is, so think of fractions. If we had x over y minus maybe a over b, for us to find an LCD, we just multiply these two together, where the LCD is just going to be yb. And then here we're going to have xb on top. It's going to be minus ay. And maybe that might be a little bit of a challenge. Okay, why is it 1 minus cos of 2x? We took out this as a common factor. I always say to my students that reversible math is correct math. Remember, if we multiply this in, we're going to get cos. If we multiply it back here, we're going to have cos of x multiplied by cos of 2x. So we took out a common factor from the top. Okay, I think everyone is covered now. Now, let's move on. Let's look at this one now. We are given cos of 60 over sine of x minus sine of 60 over cos of x is equal to 2. Show that that equation can be written as what? As cos of x plus 60 is equal to cos of 90 minus 2x. So we need to manipulate this whole thing until we get what? Until we get it to become this. So check what I'm going to do. I'm going to try and find an LCD. How do I find an LCD? You multiply the two denominators. So my LCD is simply going to be sine of x multiplied by cos of x. Okay, now what's going to happen up here? I'm going to have cos of 60 multiplied by cos of x. Then there's a minus sine of 60 multiplied by sine of x. This is still equal to 2. And then what's next? Let's see if we can cross multiply. Cos of 60 multiplied by cos of x minus sine 60 degrees multiplied by sine of x is equal to what? 2 sine x cos of x. Remember, this is over 1. And then when you cross multiply, that's going to multiply there, this is going to multiply there. Now check your formula sheet. What do you know about this guy? It's a compound angle. For what? For cos. So this is simply x plus 60 degrees. On the right hand side, this is also a double angle. And this is the same as what? Sine of 2x. Now, the left-hand side, we leave it as it is, cos of x plus 60. And then we are looking for what? Cos of 90 minus. Now you need to think about what? About co-functions. Remember, sine of 2 theta is the same as cos of 90 minus 2 theta, or 2x in this case. So all we did, we checked what this is, looking at our formula sheet. This is the compound angle for cos. You're just going in the reverse direction now, from expansion to where you started. And then it'll give you cos of x plus 60. Now, looking at the double angle for sine, it goes back to sine of 2x, or sine of 2 theta. Now, what we want is cos of 90 minus, remember, co-functions. And just like that, we got our 3 marks. So somebody's asking, why does the 2 get the LCD? So think of it this way. If you have 5 over x is equal to maybe 10, how do we solve such? We just say the 10 is over 1 and we cross multiply. Just make an x like that, where the 10 multiplies with the x and the 5 multiplies with the 1. And then finally, you can solve. That's exactly what we did. We cross multiplied in order to get rid of the denominator. Okay, I think we are all on the same page now. If you want to take a screenshot, do so quickly. Then we can quickly move on. I do have questions that I would like you guys to attempt as well. Perfect. Let's quickly move on. Okay, now here they want us to what? To find the general solution. Okay, and do you understand what they're saying? They're saying hence, meaning that you do not have to recalculate. You do know, we've just calculated, we do know what it is. We do know what this is. Check what I'm going to do. This is equal to what? Cos of x plus 60 degrees is equal to cos of 90 minus 2x. Now, because we have cos and cos, it means that the angles have to be exactly the same. If these two things are equal to each other, provided that the ratio is the same, the angles have to be the same. That is why I'm going to say x plus 60 is equal to what? It has to be either positive or negative. 90 minus 2x. Right? Plus, we have to say plus k 360 degrees. The angles are the same. Now, why is it plus or minus? That way we are dealing with all the quadrants. Because so far we don't know where it is. So if I say plus or minus, I know I'm dealing with the plus in here, the positive in there. And if I'm saying negative, I'm dealing with it if it's in there. I'm sorry, this is negative as well. Let me just say this, negative, that's positive definitely. Causes positive in there, causes positive in here, it's negative in there, and it's negative in there. So I need to address all those quadrants. And it's just a matter of finishing up. X plus 60 degrees is equal to 90 minus 2x plus k multiplied by 360. Or x plus 60 degrees equals to what? Negative 90 plus 2x plus k 360 degrees. Now it's just a matter of solving. 3x is equal to 30, if you take the 60 over to the other side, plus k 360. Solve the other side as well. Or what? Negative x is equal to negative 120 plus what? Plus k 360. And then it's just a matter of cleaning it up. X is equal to what? 10 plus k times 120. Or x equals to 120 minus k multiplied by 360. Now, because I'm done, this thing needs to make sense because we don't know what k is. We finally have to tell them that k is an element of integers. If you do not include this thing, then what we have done so far makes zero sense. We don't know what k is. You have to tell them that k is an element of integers. We've divided throughout by -1. Did I make a mistake somewhere? Let me just double check. Negative 90 minus 60 equals to negative 50. Let me just double check. I could have made a silly mistake. Okay, so the positive one, I'm gonna have negative, and then oh, okay, I'm with you guys. My mistake here. I was looking at the left-hand side. I see that my mistake is on the right. Thank you so much for the correction. Let's quickly correct it. So the mistake is starting here. let's check what happened. So when I take this over to the other side, what's going to happen? I'm going to have x equals to negative 150 plus 2x plus k 360. And then I'm going to bring the 2x over. So it's going to be negative x is equal to negative 150 plus k 360. And then we solve by dividing throughout. Thank you so much for spotting that silly mistake. In my mind, it's a positive 90 and I'm subtracting 60 from it. Okay. Let me just quickly run you guys through what I just did there. So all we did is we had solved this in the previous question and I took it as it is. Like we solved it. I equated it. And then I said, for this to be true, the angles need to be exactly the same. For the statement to hold true, the angles have to be exactly the same. Right? Now, I took the left-hand side as it is, x plus 60, and the right-hand side angle as my reference angle. Okay, that reference angle could either be positive or negative. And then I split it. So here's the positive side, and this is the negative side. From there onwards, it's simple algebra. We were trying to solve for x. And just like that, we got our answer. Okay, we did the positive side here, and we did the negative side there. Right, remember you don't have to do the fourth quadrant because this is a general solution. So we have the positive answer and we also have the negative answer. Right, now because we said k multiplied by 120, we have dealt with both the positive and both the negative, both the positive and the negative, because it's a general solution. It's not a specific solution where they give us restrictions. Why is it negative 150? We just dealt with that. Negative 90 minus 60 gives you what? Negative 150. It's absolutely unnecessary to find that solution in the fourth quadrant. Okay, now let's move on. I'm going to give you this one to attempt before we mark it together. I'm hoping you guys can clearly see it. It simply says, if sine of a is equal to 3 over 5 and cos of a is less than 0, determine without using a calculator the value of, firstly, sine of negative a, and then secondly, tan of a. It's going to be easy for you guys to attempt. Remember, this is Pythag-based trig. So you need to draw that or determine that quadrant for yourself first. It'll be easy for you guys to quickly find that. I'll give you guys a minute to attempt it and then we do it together. If you're struggling, don't worry, just attempt. Wherever you stopped, I'll give you guys the solution. But please make sure that you're attempting these questions with us. Once again, to the guys who are watching live on TikTok, if you'd like to be a part of the Zoom audience, please do check our messages there. Check our chat box. There is a link provided to you guys so that you can join us, so that you are able to interact with us and ask some of the questions that you might have. Otherwise, please help us by promoting our social media pages. Do like, follow, throw some comments here and there, and also do share the pages with your friends. We do make amazing learning content. Okay, there are answers in the chat already. We are all in agreement because we are getting -3/5. Okay, so remember that they gave us sine of A is equal to 3/5. Now this is the same as sine of 360 minus A. Whenever we're dealing with a negative angle, we add a 360 in front. 360 minus becomes negative sine of A. What do you know about sine of A? Sine of A is 3/5. But the negative sign there, because we are dealing with a negative angle. Now, the next one, they're looking for what? For tan of A. I'll give you guys 1 minute and 30 seconds to do that one as well. An easy 2 marks for us to get there. Okay, so if there are some questions that you guys don't understand, let's wait until the end of the session, once we have completed most of the questions that I've prepared for you guys, and then we'll see if we have time to come back and attempt them. Okay, I'm getting a -3/4. I'm also getting a +3/4. Which one is the correct one? Try to be quick. We always say, look at the mark allocation. If the mark allocation is 3 marks, then it means you cannot spend anything more than 3 minutes on that particular problem. Okay, 25 seconds left. Okay, we still have different answers there. Okay, let's see how to tackle this. Now, our small cast diagram, they're saying sine of A is 3/5. 3/5 is a positive answer. It means that sine is either in there or in there. Furthermore, they say that cos of A is less than 0, which means that cos of A is negative. Where is cos negative? It's negative in there and in there. Now it means that we are in the second quadrant. And sine is y/r. So this is 3 and this is 5. It's going to be easy for us to find x. X will be -4. This is a 3, 4, 5 triangle. You can use Pythag. X squared is equal to r squared minus y squared. So 5 squared minus 3 squared, 25 minus 9, which is 16. X equals to plus or minus the square root of 16. X equals to -4 because it's on the second quadrant. Now we can write tan. So tan of A is equal to y over x. What is the y value? 3. What is the x value? -4. So your answer is -3/4. And just like that, we have our 3 marks. Okay, there is a hand that is raised. I'm going to ask that they help you unmute yourself. Pete, you can go ahead, unmute yourself. We're listening to your question. Beat Mashishi, you can unmute yourself and ask the question before we quickly move on. Otherwise, in the meantime, you can take a screenshot if you need to do so. Okay, maybe it was a mistake. Okay, quickly moving on. Now, cos of 34 is equal to P, right? Without using a calculator, write down the following in terms of P. First one is they want cos of 214. Okay, how do we deal with such questions? It shouldn't be a problem at all. This angle, can play around with it. You can say this is cos of what? 180 plus what? Plus 34. Because 180 plus 34 gives us what? It gives us 214. Okay, there's a question, sir. Why are we working in the second quadrant? Remember, we checked by using the text. They gave us a restriction. They said sine is 3 over 5. Sine is positive in the first and second quadrant. They gave us another restriction where cos is less than 0. So cos is less than 0 in the second and the third quadrant. Then we always check where we have two ticks, and that's the quadrant that we're dealing with. Okay. Just a second. Let's clean up the questions here. Okay, perfect. Now, cos of 180 plus is in which quadrant? The cos diagram is very important. 180 plus is in this quadrant. What do we know about cos in there? It's negative. Cos of what? Cos of theta. And theta in this case is 34 degrees. Now, what do you know about cos of 34? It's just P. That's why our answer is negative P. We're all getting the same answer. Perfect. Now, the next one is cos of 68 degrees. Okay. Because we're dealing with 68 degrees, we need to establish the relationship between 34 and 68. There's always going to be some sort of relationship, right? It's either you can create a cofunction or you can have a double angle. Now, this is a double angle. So 34 is half of 68. So I can say that cos of 68, not 60, but 68. Sorry about that. Cos of 68 is equal to what? Cos 2 times 34 degrees. Now, giving you guys a hint. I'm going to give you guys 1 minute to quickly carry on with it. If you have an answer, you're more than welcome to post it in the chat. Okay. LT saying we must use the double identity. And then there are different answers in the chat. Thank you so much for attempting it. Please make sure that you do attempt the questions, just so you can see when I give you guys the solutions if you're on if we're on the same page or not. Okay, you have 20 seconds left if you're still attempting it. Okay, I'm seeing different answers in the chat. Great stuff. Perfect. Let's quickly look at this. This is a double angle, and then we're going to say this is what? 2 cos squared 34 minus 1. Now, I can simplify it further and say cos squared 34 is the same as what? It's the same as cos 34 multiplied by cos of 34, so that you can see clearly where this is coming from. What do you know about cos of 34? What did they say? It's p. There is another p. Remember, this is multiplication. 2p squared minus 1. This is our final answer. Well done, guys. If you got it, just give us a thumbs up. If you're not getting it, maybe just give a heart there so I can quickly re-explain it to you. Okay. So all I did is I established the relationship between 68 and 34. I know that 34 goes into 68 twice. That is why I say 2 times 34. Remember that 2 and 34, 2 times 34 takes you back to what? To 68. But now remember something. What is cos of 2 multiplied by theta? That is the same as what? 2 cos squared theta minus 1. And that's what I did as well. I said 2 cos squared. Theta in this case is the 34 minus 1. Now remember something. That cos squared of theta is the same as cos of theta multiplied by cos of theta. So I broke it apart for you guys to see there. Cos of 34 is p. We have another cos of 34, which is p. P multiplied by p gives you p squared, and multiplied by the 2, the 1 is still subtracted there. Now remember, there are multiple methods that you can use, and if you have a different method but you're getting to the same answer, that's perfectly fine. I cannot do all the methods for the sake of time, but I will try to use the methods that I think are quite easy to comprehend. But if you feel like your methods are easier than mine, that's perfectly fine. You can carry on using your methods. Okay, moving on. Now the next question is, they're looking for tan of 56 degrees. Let me just move this up so we can clearly see. Tan of 56 degrees. It shouldn't be too much for us to do. They're saying we can use 90 minus 34, but then if you did that for tan, you are going to end up with cot. So tan of 90 minus 34 is cot. Then you're going to have some problems. So shy away from the cot. There we go. There's a question. What is cot? That's why I'm saying shy away from it. So in high school, they only focus on sine. Well, maybe in grade 10, they used to also introduce you to the other 3 ratios, which are cosec, cot, and sec. Those are the reciprocals of sine, cos, and tan. Okay, there's another one. Third angle of the triangle is 56 degrees. Okay, if that's what you meant, then perfect. Let me help you guys out. We have 34 degrees here. We know that we're dealing with a 90-degree triangle. That's given. Now, what would this be? This would be 56 degrees. How do we know that it's 56 degrees? These two need to add up to 90 degrees so that the interior angles of a triangle add up to 180 degrees. Now cos was how much? Cos was p over 1, which is the adjacent side. And then it's easy for us to find what this is. And that is simply going to give you what? 1 minus p squared under a square root. Please, I repeat, do not be tempted to say that this is 1 minus p. Doesn't work that way. Now that you have that, we can solve for tan of 56 because tan is y over x. What is the y value? The y value is 1 minus p squared under square root. And what is the x value? The x value is p. But what are we looking for? We are looking for 56, not 34 degrees, right? So we have to say tan of 56 degrees is what? It's the opposite side. Be very careful. 56 degrees is the angle in question. Opposite side, which is p in this case. The adjacent side is what? 1 minus p squared under a square root. If you did this, you would have done it for 34 degrees instead of 56 degrees that they are looking for. Hoping that's clear for everyone. Okay, quickly take it down so we can move on. Okay, perfect. I'm going to skip some of the questions so that we can look at these kind of problems as well. Okay, let's just scroll down. 3D trigonometry. We can clearly see the question there. Let's check what's happening here. Express TR in terms of theta and K. TR. Where is TR? This is the TR that they're talking about. Now, immediately I wanted to use triangle TRS, but I do not have enough information. The reason I was inclined to use that one is because I saw the 90-degree angle there, and that's why I wanted to use it. But I cannot use it. I have to rely on something else. I can use triangle TQR. Why? Because I have enough information there. So if I highlight this triangle, just bear with me for a second, you'll see what I want to do. So it's a triangle that looks something like that. I have a K here, I have this angle as theta, and I have this angle here as 60 degrees. And then this is my R, this is T, and this is Q. What can we use? There's a special rule that we can use here. If you think you know what the rule is, please do type it in the chat. What rule can we use? The sine rule, right? We have to use the sine rule. We cannot use the cosine rule because the cosine rule needs a lot of sides. Here we are only given one side and we want to find another side. So we'll use the cosine rule, sorry, we'll use the sine rule. The sine rule, we will say in triangle TRQ, side TR over sine of 60 degrees is equal to what? Is equal to K over sine of what? 180 degrees minus 60 degrees minus theta. All I did is I tried to find this angle using interior angles of a triangle. Remember, R is equal to 180 degrees minus what? Minus 60 minus theta, which simplifies to 120 minus theta. That's where it comes from. Hope everyone can see it now. Then this is TR over sine 60 is equal to K over sine 120 minus theta. Hope everyone is with me there. Then we just need to multiply both sides by sine of 60. These two will cancel. Whatever we do on the left, we need to do on the right. So TR is equal to K sine of 60 over sine of 120 minus theta. Okay, let's quickly address 10.1 again. Express TR in terms of theta and K. So the side that we're looking for is this side. That's what we need to find. Now I'm going to extract the blue triangle. I know this angle here is theta. It's given there. They gave me the other angle as well, which is 60. This angle, we don't know, but we can quickly find it by using interior angles of a triangle. And if you use interior angles of a triangle to find angle R, you're going to get it to be 120 minus theta. Now, we're in agreement that we can use the sine rule. Okay? So if we're using the sine rule, we can say what? TR over what? Over sine of 60. So remember, it's the side and the angle that it's opposite. So this, I always say it's an I. Where is it looking? It's looking there. So it goes together with that side. That's why I'm saying TR over sine of 60 is equal to what? Is equal to K. I cannot use QR because this is also unknown. So I have to use what is given. That's why I'm saying K over what? Over this angle. These two go hand in hand. K over sine of, if you want to say 120 minus theta, that's perfectly fine. I was just showing you guys where I got it there. Okay, now once you have that, you can simplify TR over sine 60 is equal to K over sine of 120 minus theta, right? And then from there, you simply multiply both sides by sine of 60, right? If you don't want to use the both sides one, if that's confusing, I see there's a question. So all I did, think of it this way, TR over sine of 60 is equal to K over sine 120 minus theta. You cross multiply. What are you going to have? TR sine of 120, not 12 theta, but 120 minus theta is equal to K sine of 60. And then you divide both sides by what? By sine of 120 minus theta, where these two cancel each other out. I'm hoping it's clear for everyone. Okay, perfect. Now they're saying, show that RS is equal to 3K all over 2 into root of 3 cos of theta plus sine of theta. Okay, let me just erase this so I have some space to do this. I want us to look at triangle TRS, the 90-degree triangle. Just hold on for a bit, just so everyone knows where we are. Now, in that triangle, we know that in triangle TRS, we know that RS over TR is equal to what? Is equal to sine of RTS. Now, RS is equal to, it's equal to TR, sine of what? RTS. But remember that angle T of RTS is 60 degrees. If you simply wanted to say sine 60, that's perfectly fine. Hope everyone is with me there. Okay, I see Puling has their hand raised. Puling, let's allow you to talk. Puling, you can unmute and ask your question before we carry on. Puling, you can unmute. Okay, I'm going to assume it was a mistake. If you want to ask the question again, you will raise your hand. Okay, maybe let's take it from the top. I see a lot of people are confused. So we're looking at the blue triangle now. So in the blue triangle, so in triangle what? The right angled triangle, in triangle TRS. Sine of 60 degrees is equal to what? Is equal to RS over TR. Hope everyone is with me there. Then this is over 1, remember. Cross multiply. The RS is going to multiply with the 1, and then the TR is going to multiply with sine of 60. Now check something. We said that RS is equal to what? TR sine of 60. But what do we know about TR? That's all I'm going to do. Take it as it is. K sine of 60 degrees all over sine of 120 minus theta. Sine of 60 degrees. Now it's just a matter of using special angles. This is going to be K sine squared 60 over sine 120 degrees plus theta. But remember something. This is a compound angle. Can you see? This is a compound angle formula sheet. I know it's going to become sine of 120 multiplied by cos of theta minus cos of 120 multiplied by sine of theta. Okay, then this is K, division line. What is sine of 60? It must give you what? Root 3 over 2, but it is squared. And then the rest is just calculator work. What is sine of 120? Root 30 over 2 multiplied by cos of theta minus what is cos of 120 degrees, negative 1 over 2. Sine of theta. Okay, looks like everyone is still following. Then on top, what are we going to have? We're simply going to have k with a 3 over 4 all over the numerator. The denominator is still the same. Now, what is it that they wanted? They wanted a 3k. So what I'm going to do is I'm going to multiply the top by 4. I'm going to multiply the bottom by 4. So 4 over 4, think about it. This cancels that. So I haven't really done anything to the equation. There's a question. So why is it negative a half? What is cos of 120? Okay, I see what you mean. I need another negative. So let's do this quickly. There we go. Thank you. Then we know that this part, the 4 that I multiplied with, cancels that 4. What are we left with on top? We are left with 3k. Okay, if you multiply this 4 in, what are you going to be left with? You're going to be left with 2 root 3 cos of theta plus what? What is 4 multiplied by half? 2 sine of theta. Is this what they were looking for? No, but we are almost there. We just need to take out a common factor of 2. So on top, you still have 3k. Take out 2 as a common factor. You have root 3 cos of theta plus sine of theta in a bracket. Let's check. Are these exactly the same? They are, which means that this is the correct answer. Perfect. Now here's another diagram-based question. I'll quickly let you guys attempt it before we move on. But I'm going to give you hints. Please make sure that you do attempt it. Given sine of theta is equal to 12 over 13. People just want to take a picture. Let's do this quickly. But the notes will be shared with you guys. But you can take a screenshot. The notes will be made available to you guys. Okay, perfect. Given sine of theta is equal to 12 over 13, and theta lies between 90 and 360, lies between there, not including the 90, not including the 360. With the aid of a diagram and without the use of a calculator, determine the value of sine of theta. Sine of 2 theta, not theta, sine of 2 theta. What do we need to do there? You need a diagram. I'll give you guys 2 minutes for this problem, and then we're quickly going to mark. Okay, while you guys are working on it, Beat, you can ask your question. Beat Mashishi, you can unmute and ask your question since your hand is raised. that's not a question. You have 1 minute and 30 seconds left to attempt that problem. And we're quickly going to mark. Yeah, answers in the chat. Thank you so much. You're left with 50 seconds. Okay, looks like we're all getting the same answer. Some got positive, some got negative. Which one is it? Let's check. So with the aid of a diagram, let's check. Sine of theta is 12 over 13. So 12 over 13, is that positive or is it negative? It's going to give you positive. So it means it's either in there or in there. And let's look at the next restriction. Theta lies between 90 and 36. So between 90 and 36 is either there, or here. Now, which one has two ticks? Which quadrant has two ticks? Quadrant number 2 has two ticks. So it means that our diagram is going to be in there. This is 90 degrees. Immediately, this is going to be 12, and R is going to be 13. Now, we want sine of 2 theta. What do we know about that? Sine of 2 theta is equal to 2 sine of theta cos of theta. Then this is going to be 2. What is sine of theta? 12 over 13. But now we are stuck. We need to find cos. Cos is x over r. We don't know what the x value is, but we know that x squared is equal to r squared minus y squared. 13 squared minus 12 squared, 169 minus 144, 25, x equals to plus or minus 5. Which value is it going to assume? The negative 1, because it's on the left-hand side of the y-axis. Okay? Now, let's substitute that. We're now going to have how much? We're going to have negative, excuse me, sorry about that. Let's quickly find where we are. There we go. This is going to be negative 5 over 13. Then from there, we know the top is going to be 120. The negative is still in front. And then 13 times 13 is 169. And just like that, you have 5 easy marks. Not too much of a problem there, right? Perfect. Okay, so somebody's asking, please explain why is it quadrant 2? Remember, we rely on the information that they give us. They say that sine of theta is 12 over 13. On your calculator, if you press 12 over 13, you're going to get positive. Right, now we need to check. Sine is positive in here or there. Those are the options. Furthermore, they say that theta is between 90 and 360. So this is 90 and 360. And remember, we always go anti-clockwise. So it's either in here, there, or there. Now, where do we have two ticks? In the second quadrant. That is why it is quadrant number 2. It looks like everyone is covered now. Okay. Now, the last problem that we're going to look at is this one here. Okay. Let's see what they're saying here. Simplify without the use of a calculator. Right. For 7 marks, I'm going to just show you the mark allocation, and then you can see where you're going to get your marks. The mark allocation for this previous question, you're going to get, so it's out of 5. You need to include a quadrant with theta. So because we're dealing with sine of theta, let's not forget to say this. That's where it is. That's the value of theta. That is a mark. Right? You must also indicate these two. And then there's a mark for the -5. There's a mark for expansion. There's a mark for substitution and the final answer. Okay, cool. Now this question here. So sine of 360 minus, what does that simplify to? Okay, this thing is misbehaving. Let's quickly fix it. Sine of 360 minus is the same as negative sine of theta in brackets multiplied by, now cos of 360 plus theta. This takes you back to the first quadrant, which is just cos of theta. Sine of negative theta, we put a 360 in front, so it becomes 360 minus theta, and this is negative sine of theta. This is then all over cos of, but it's a cofunction, so it's going to change to what? To negative sine of theta, because it's in the second quadrant where it is negative. Remember, we deal with cos first before we change. And then this is simply going to become what? Tan of theta. Now at this step, you have a mark there, another one here, negative sine and positive tan. So immediately you have 5 marks. Even if your algebra is not very strong, you have 5 out of 7. Now it's just a matter of simplifying. This is then going to become negative sine of theta multiplied by cos of theta minus sine of theta, but it's multiplication. This is then all over negative sine of theta multiplied by sine of theta over cos of theta. This cancels that. What are we then left with? This cancels that. But the negative remains. Negative cos squared of theta. Where's the other mark? Here, and the final answer. As easy as that, you have gotten 7 out of 7 marks. I'm hoping it's clear for everyone. Okay, perfect. And just like that, we have concluded the lesson for today.